Hi-Lite II is a versatile and simple to install LED accent tube from the Visiv group. In this video we'll be looking at how to fit Hi-Lite to a building fascia or feature using this mock-up of a shop front behind me. We'll cover the basics of selecting and specifying the correct components, how to deal with corners and other features, as well as commissioning and fault-finding techniques.
First, let's take a look at the components that make up a Hi-Lite II system. The tube sections themselves are factory sealed and tested to ensure that they're fully weatherproof. Standard sections are usually 2.4 meters long, but for this demonstration we'll be using shorter lengths, which we just happen to have in stock, so we can show the joins between sections more easily. Sections are connected together to form longer runs, and when a section shorter than 2.4 meters is needed at the end of a run, custom sizes can be ordered directly from Visiv Group, or a special on-site adjustable section can be used to finish the job in one hit. We'll be covering both options in this video. The tube sections are mounted to the structure using clips. Two types of clip are supplied, a standard 45mm long clip, which should be mounted at a maximum spacing of 400mm, and a longer 90mm bridging clip, which spans the join between sections, ensuring that the adjacent tubes are perfectly aligned. The Hi-Lite II system also includes a range of power supply units for both external and internal use, ranging in power output from 20 watts to 240 watts. Power supplies intended for outdoor use are fitted with our patented CSC safety monitoring system, which we'll look at in more detail later. Included with the power supplies are some blanking plugs, which are used to blank off unused connections at the end of a Hi-Lite run, as we'll see in a moment. Finally, in order to get power from the power supplies to the tubes, we need some connection cables. Hi-Lite II uses a plug-and-play connector system, with pre-terminated cables simply plugging into power supplies and then into tube sections. Jumper cables are used to bridge gaps in tube runs, for example around other signage, service ducts and pipework.
No special or unusual tools are required to install Hi-Lite II. In fact, very few tools are needed at all. You will need a tape measure and a drill and driver for fixing the clips, and a method of ensuring the clips are mounted in a straight line, such as a chalk line or laser level. A simple digital voltmeter can be useful for fault finding, but it's by no means essential.
If you are using the on-site adjustable section, then you will need a few additional tools. A hacksaw fitted with a fine blade for cutting the section to length, a mitre block to ensure a square cut, and a sealant gun for applying the adhesive sealant to fix the end cap.
Now, whilst our mock-up fascia is at ground level, most real-world installations are at height. Make sure to follow all relevant codes with regard to risk assessments and always use appropriate access equipment and PPE. Now, just before we actually start to fit some Hi-Lite II sections to our structure, let's take a quick look at how you might survey a site. In order for Visiv to build a kit of parts that will fit your structure exactly, an accurate survey is essential.
Measure each continuous run and supply the measurements to Visiv as is, with no deductions. Visiv will calculate the required lengths, allowing room between sections for thermal expansion. All tube sizes given by Visiv are nominal, and it is important that dimensions submitted are the gap that the Hi-Lite run is required to fill. The only exception to this is when dealing with internal corners. If the Hi-Lite run is to continue on the adjacent face, you will need to subtract 50mm from the elevation measurements to allow for clearance. Although not absolutely required, it is recommended to subtract 50mm from both elevations, so the corner will appear symmetrical, as shown on this mock-up. The alternative is to allow one tube to overlap the other, but this is not normally recommended. External corners are slightly more straightforward, and usually don't require any adjustments to be made to the measured dimensions. Because the ends of the Hi-Lite tube sections illuminate, simply bringing the tube section in line with the structure edge will usually give the best visual result. Don't be tempted to overlap the sections as shown here, it does not normally give a good visual effect. If your installation requires a run of Hi-Lite II to include gaps for logo signs or other features, don't forget to measure for any jumper cables that may also be required. However, if the gap that you need to span is less than 200mm, a jumper cable is not normally needed, as the connection tails from the tubes will reach directly.
So we've surveyed our site, ordered the parts we need, and have all the necessary tools ready to go. So let's get started and look at how to actually fit Hi-Lite II to our fascia.
The first step in the install process is to fit the fixing clips, which hold the tubes in place. There are a couple of important points to remember when installing the clips for a Hi-Lite II installation. Number 1, use enough of them. Keep the spacing to 400mm or less to avoid the tube bowing as it expands and contracts with changes in temperature. Secondly, take the time to fix them in a straight line. If you install the clips along a wobbly line, then the tube will follow, ruining the look of the install. Running a chalk line or laser level across the fascia is well worth the effort. As mentioned earlier, there are two different types of clips supplied with the Hi-Lite kit. The 90mm bridging clips are fitted first, at a pitch equal to the nominal length of the tubes. So, starting at one end of your elevation, fit a 90mm clip 2.4 meters from the end. That's assuming that you are using the normal 2.4 meter standard lengths. In our demonstration, remember, we're using shorter lengths, 1150mm to be precise. So we are going to fit our 90mm clips at this pitch. Fit further 90mm clips at your standard length pitch all the way along your fascia elevation. Next, fill in between the bridging clips with the standard 40mm clips, maintaining a clip-to-clip spacing of 400mm or less. When you come to the end of the elevation, fit a clip approximately 40mm in from the end. Once all the clips are in place, you can move on to installing the power supplies and low voltage cabling. For external projects, Visiv will supply an IP rated driver suitable for direct mounting outside. However, keeping the units protected from direct sunlight will extend their service life, particularly in warmer and sunnier climates. The low voltage cable run to the first Hi-Lite tube should be kept below 10 meters, so again consider this when positioning the power supplies. Once a suitable location has been identified, fix the drivers in place. For our demonstration, we have mounted the power supply just below the fascia mock-up. Now, the supplied power supply cables can be routed from the power supplies to the fascia. On all but the smallest installations, dual output feeds are used, so two cables are routed together and are passed through the fascia each side of a bridging clip. Decide which clip will be your feed point and drill a 10mm hole either side of it. Then route the supply cables from the power supply to the fascia, bringing them out through these holes. If your fascia material has sharp edges, use a grommet to protect the cable from damage. Obviously you'll have to increase the hole size to suit. Notice that the connections on the power supply outputs are female, and that the power supply connection cables are in effect extension cables and so present a female connector to the tube. Therefore, any tube sections running to the left of the feed position will be installed with their male connectors at the right hand side, while the tube sections to the right of the feed position will have their male connectors on the left hand side. I hope you got that. Now that we have our clips and low voltage feed cables ready, we can go ahead and fit the tube sections themselves. When unpacking a tube section from its bag, you will notice that there is a single 40mm clip already attached near to the male connector end. This clip is not used to fix the tube to the fascia, but instead is used to hold the cables and connectors behind the tube out of sight. Make the connection to the power feed and then slide the free clip over the cable and connector. Now push the tube into its clips, working your way to the other end. At the other end, loop the cable around, ready to connect to the next section. It's important that some spare cable is left here to allow for movement due to thermal expansion and contraction. If this cable is pulled tight at this stage, it can lead to premature failure. Push the end of the tube into the bridging clip, making sure that the cable is freely located and not trapped between the tube and the clip. Now the next tube section is fitted in exactly the same way, and this process is continued all along the elevation. If you have accurately positioned your bridging clips at the correct pitch, you will find that the expansion gap between sections will automatically be maintained. Although the exact gap will vary with the ambient temperature during the install, you will generally find it to be between 10 and 15 millimeters. When you reach the end of the elevation, if you have a made-to-order kit, simply fit the relevant custom section in the same way. If this is the end of the electrical circuit, be sure to fit the blanking connector supplied with the power supply unit to ensure water cannot get in. Because the power supplies contain a monitoring system, which we will look at shortly, any rainwater getting into this end connection will cause the power supply to go into fault mode. If you are using the on-site adjustable Hi-Lite section instead of a custom-made part, now is the time to cut this to length. First, accurately measure and note down the gap that you need to fill. Subtract 25 mm from this dimension and find the mark on the adjustable tube that is closest to this value but smaller than it. This is where you will cut the tube. Using a mitre block and a hacksaw fitted with a fine pitch blade, carefully cut the tube at the mark, following the dashed line and being careful not to encroach on the hatched areas. Discard the offcut and remove any swarf from the cut end. Now apply clear Dow Corning 794S or 799 adhesive sealant to the rubber end cap as shown, before sliding it over the end of the tube. Check that the sealant forms a complete bead and then set the section aside for as long as possible to allow the sealant to skin. Note that the adjustable section should not be installed before the sealant has fully cured if bad weather is expected. Once the sealant has cured sufficiently, the section can be fitted into place. If the electrical circuit is to continue after the adjustable section, for example around a corner, run the supplied jumper cable along the back of the tube and past the sealed end. Otherwise, fit a connection blanking plug to the unused connector on the cable loom. The sections to the other side of the centre bridging clip are installed in the same way. Because we fixed our first clip exactly one standard length away from the end, we won't need a custom size this time.
Now that we've finished installing all the tube sections, we can connect the feed cables up to the power supply and power on the installation. I hope you will agree that Hi-Lite II is very straightforward to install, and if you follow the instructions in this video and in the printed installation manual carefully, you shouldn't run into any problems. However, as with any technical product, things do occasionally go wrong, either at the time of installation or sometime later. Here are some tips for identifying and dealing with faults should they occur.
One of the simplest ways to troubleshoot a problem installation is to use the CSC system on the power supply. All CSC equipped units, whether they feature 1 or 2 channels, include LEDs which can be used to determine the status of the Hi-Lite install. A green light indicates that all is well. If the status LED is green but the tubes are not lit, then investigate whether you have volts on the power supply output and at the end of the low voltage supply cables. Standard Hi-Lite II systems operate on a nominal 46 volts DC, so if you don't measure this coming out of the supply, a faulty power supply is the likely cause. A spare jumper cable can be modified to provide an easy way to test the supply voltage. If the status LED is flashing red, the output will be switched off as the CSC has detected a fault. The number of pulses indicates which of the CSC tests has been triggered. 2 pulses indicates a startup impedance test failure, so a low resistance has been measured across the output at startup. This can be caused by a faulty or damaged tube section, badly made connections between sections, or water inside the connectors. 3 pulses shows that the system has detected changes in the current being drawn by the Hi-Lite II tubes. This is usually caused by a damaged tube or an intermittent connection between sections. 6 pulses indicates a runtime voltage test failure. This test is carried out at 10-second intervals all the time during normal operation, and a failure usually indicates that there is water in the system somewhere. Look for physically damaged tube sections that may be allowing rainwater in. If you connect too much tube to one power supply channel, you'll see the status LED flash 8 times. This is an overcurrent failure, so reduce the load on the output channel by installing an additional power supply. Should the mains input to the power supply be cycled when the system is in fault mode, the CSC first attempts a power-up. If this is successful, with no faults being recorded, normal operation resumes and the CSC enters its continuous monitoring mode once again. For further details on the operation of the CSC, including information on all of the tests that it performs, please take a look at the printed manual.
I hope you found this video guide useful and you now feel confident and competent to go out and install Hi-Lite II on any site. Remember that if you do run into any problems or you want to talk through a particularly difficult or unusual installation, Visiv engineers are always on hand to help. Just give us a call or send us an email and we'll do our very best to guide you through.